strands in order to give the healthiest feeding mixture possible. Matrix P gives the portion of the mixture for each brand, okay? So it has it broken down based on nutrient. So which matrix is defined, NP or PN? Why is it NP? And why does PN not work? Dimensions, yet again, right? So if we tried to multiply P times N, our inner products would not match, and I would not be able to multiply those matrices by each other, okay? So in order to get these values, then I just have to multiply, across my rows, across my columns, hit each one of these values with the percentages, and then add them up, and then you guys find these values that are inside of this cell here, okay? So we get what's in there, okay? All right, and then it asks for how many milligrams of nutrient 2. That would represent our second row, so we'd end up with 360.5 milligrams. I almost wonder if I shouldn't flash the key up here and if we should just work out the ones on by ourselves, maybe? I don't know. I know you guys probably want to see 12, right? 12 was a really good one to talk about, okay? All right, so if we look at 12, we've got our matrix, and then it says it gives you the cost for flying, first class, whatever, that's in those values. We have 4 different airlines, so A, B, C, and D, okay? And then it says, suppose that the prices in matrix P are all going to increase as follows. So A goes up 5%, B 4, C 6%, and airline D goes up by 2%, okay? The wording of this question is what makes it a little difficult, but it says write a 4x4 matrix N such that the product, when you multiply it by P, is the new price matrix, okay? So that means like we want to write something, or we want to figure out a matrix such that all of the costs for airline A are going to increase by 5%, meaning we want to multiply it by 1.05. That's what would increase it by 5%, okay? So I want the result, all these multiplied by 1.05. All these for B are going to multiply by 1.04, 1.06, and then 1.02 as a scalar multiple in front of all those values, okay? So we need to figure out what that matrix is going to be, okay? So the way that we have to word it, and it ends up being a 4x4, even though this is a 4x3, and the reason being is because we're not thinking about it like, matching like each one of those cells individually, but we're trying to figure out, okay, I need to multiply by something on the right such that when I multiply, so P times N is what I want to end up with. I'm doing by my row and then by my column. And what I want to end up with is the proper scalar multiple that goes with each one of those values, okay? So if I think about like, okay, I'm going to multiply this row and then diagonally by this column. But what I want to end up right here, I want to end up with 1.05 times A sub 1. That's what I want to get, okay? So if that's the case, I'm going to multiply all these values in this first row by all these values in this column. So that's what I want to end up with there. But I don't want anything other than something that's A sub 1, so I need to put a 0 in each one of those values. So I got to so if I put a 1.05 there, I'm going to get that for the A sub 1, but then I want zeros all the way down because I don't want any of these values to get multiplied and then added into that same cell, okay? And then the same thing's going to happen like if I, keep going along the top side as well too. So like in that first column, if I multiply, along here and then diagonally, I'm also going to want zeros as well too. And then when I go to multiply my business, so if I multiply this column by this first row, I want A sub 2 to hit that 1.05, and then the rest of these I want to be zeros. Okay, and then when I go to actually figure out like, okay, I want all these values to get multiplied by 1.04 would be my next value. So then I want my next column. So if I multiply by my row and then by my next column, that first entry I want there to be a 0 because I don't want there to be anything that hits A sub 1. So I want that to be a 0. But then when I get to my value for B, I want B to hit the scalar multiple that I want for that. So it's going to be 1.04. So then that's going to go at that part of the diagonal. And then same logic as before, I want zeros below it, okay? And then when I am multiplying by my values for C, so, these two are going to multiply, and then B sub 1 times 0. And then when I get to C sub 1, I want that to get multiplied by, so if I multiply, I want that to get multiplied by 1.06. So 1.06 is going to go there, 0 below. And then my last one, of course, is going to be 1.02. So that one's a little tough to figure out. Okay, they're telling me it needs to be a 4x4 matrix. That's how they want me to do this. How is that going to work as I multiply those? That's how I'm going to build those. So that's how we end up with P times, or that's how we end up with N. So then Pn is going to be the result of that. So you see like diagonally, or not diagonally, but vertically in those columns, I multiply by each one of those values that I'm looking for. Okay, so that one's a bit tough. Okay, let's talk about 13. Any other questions on 12? Okay, let's talk 13. So with 13, we want to solve this, and we're going to use inverse matrices to do this. So let's actually do this one together, okay? All right, so for the first part, I've got a matrix multiplied by x, and then subtracting another matrix equals the value that's all the way to the right. What am I going to do first? Charlie? Cool. So we're going to take that matrix that's to the right of my value for x, and then I'm going to add it to both sides. So then I end up with 5, 3, 3, 2 times x is equal to, and then I want to add those values together. And I can do it just cell by cell because it is, matrix addition. So then what do I end up with? 2, 5, 1, 4. Sound good to you guys? After that, what do I need to do? Because there's no division of matrices, which tripped some of you guys up when we took that first quiz on this. What are we looking at, Charlie?
Multiply by the inverse.
We need to multiply by the inverse. And you need to be careful about how you do this. When you multiply by the inverse, which direction do we do it? It's very cognizant of you. I appreciate that. Where do I multiply it by?
You put it in front.
In front. Good. Yeah, I'm going to put it in front of that value. It's exactly right. Hello. Yes. So where does he need to go? Got it. Okay. Thanks. Amog. You need to go to the trainer's room. Do you know where that's at?
Yeah.
Okay. I don't, so I'm glad you do. All right. I need to multiply on the left. Good. All right, so then when I do that, I need to find the inverse of this matrix right here, okay? And you guys told me a little bit about how to do that already. I've got 1 over my determinant, which by determinant that's going to look like what? 10 minus 9, which is going to give me 1. Oh, that's pretty nice. And then I would multiply it, or then the matrix I'm going to multiply it by, I need to flip those values and then change the sign. So 2, -3, -3, and then 5. So that is going to end up multiplying my other matrix that's over here, 2, 5, 1, 4. So then we do matrix multiplication. I don't need to distribute my 1, which is kind of nice because it's just 1. I did the thing. Nice shirt, by the way. Yep.
Do you like my Chemical Romance?
I do. Oh, this is for him. All right, anyway, so I distribute a 1. I don't need to do that. So then I would just do matrix multiplication to end up with those values. And I think you guys are feeling okay on that. Okay? Are we good there? Do we want to see me multiply those out? Good? Okay. All right, cool. How'd you guys do on Kramer's augmented inverse matrices? How'd we do on those?
Good, but
Not super fun?
can we take augmented matrices off the test?
Which one?
Augmented matrices.
No. We're leaving them there. Andy, what's up?
2 by 2.
What's that?
Instead of a 3 by 3, you can just do a 2 by 2.
What's wrong with a 3x3?
Takes long.
It's not that bad.
The worst.
Listen, you guys are pros at it. We took a whole quiz on that. There's a lot of questions here. Andy, what's up, buddy?
If we solve 2 of them with the original, we just solve the last one.
Yeah, that's what they were saying. I'm fine with that. Yeah. If it's a 3x3, for example, and you find like X and Y, can I just plug those values in to find Z? Unless I otherwise state, like use Kramer's rule for every individual variable, then I am fine with that. What's up, Isabel? Yeah, absolutely. No problem. Nana, you good? Or are you gonna ask the same thing Andy was? You figured it out? Okay, cool. All right, what about for 14? Do you guys want me to do either Kramer's rule, augmented, or inverse matrices? What do you got? Let's do C. Okay, so with this one, we need to first set up, we need to set the matrices up in general first, okay? By the way, I heard your request. I made sure that there's plenty of room on each one of the questions, particularly in the first part when you guys are doing this type of stuff, so it's not all crammed in there. Because like doing A, B, and C in that space that I gave you is not great. So, all right, we need to set up a matrix first, okay? The general form of what that matrix looks like is we're going to have a matrix for our coefficients multiplied by x and y, in this case, since it's just a 2x2 system, and then equal to our solutions 4 and 10. So then we got to put our inverses in there, so 3, 5, 1, and 6. Okay. So then, Nana, I want to solve for x, y. We mentioned previously I can't just divide by a matrix, right? So then what do I need to use?
Just like the inverse.
So I got to multiply by my inverse, okay? So I got to find what my inverse is. So then that process looks like 1 over my determinant, which is going to be 18 minus 5, which is going to give me 13. And then that's a nice number to work with. And then we've got our values on the inside. So swap the 6 and the 3 and then negate the other values. So there's that. So there's our the beginnings of our inverse matrix, okay? Now, I need to multiply it by my constants, 4 and 10, okay? And Charlie mentioned this earlier, but I do need to make sure that I multiply on the left. Maybe it wasn't Charlie that mentioned that, but either way, I got to multiply on my left, so I'm going to put 4 and 10 right there, okay? So if I multiply these together, then my answer should be xy, okay? Now, that 1 over 13, Nana, you have a tendency to dive headfirst into fraction land. So here's what we're going to do to avoid that. We're actually going to take the product of these two matrices first before I distribute that 1/13 to it to try to avoid any fractions at all costs. Does that make sense? Okay, so 1 over 13, and then I use matrix multiplication. So here and then here. So then I would do 6 times 4 is 24. And then plus negative 5 times 10. So I'm going to get 24 minus 50 for my first value. And then for my second value, I got to do negative 1 times 4, which is negative 4, plus 3 times 10. So negative 4 plus 30 for my other value. You okay so far? So then I simplify that, and let's see what we get. So 1/13, and then 24 minus 26, or 24 minus 50 is negative 26. And then negative 4 plus 30 gives me positive 26. Oh my gosh, those are divisible by 13. So then we end up with negative 2 and positive 2 for our values for x and y. Do be sure you write your answer as a coordinate pair. So negative 2, 2 is how I would want you to express your answers for every one of those points. What's up, Nana?
So do you want us to do the negative 2 and 2 for like all three?
Yeah.
All right.
Yep. Are we okay on A and B? You guys good on Kramer's and augmented? I feel as if we should do those for 15 though, right? All right. Okay. Let's cram it up. Okay, how does this work? How do we do Kramer's rule?
I don't like Kramer's rule. I love Kramer's rule. Kramer's rule is my favorite thing we've done.
Perfect. I love to hear that.
Well, you take all the
Coefficients?
coefficients,
There it is.
pull them down into the bottom determinant.
Yeah, so we're talking determinants, right? We need to pick a variable to solve for first.
X.
Fine, x it is.
Sorry, guys.
X every time.
Are you trying to be different?
And it is one determinant divided by another determinant, yeah? Okay, so let's remind ourselves how this works. Let's do bottom determinant first because that's easiest, right? Gideon. Can you,
He's going for the lap record.
what'd you say?
I got this question.
I know, I understand, but I'm not going to give you a free pass to do whatever it is that you're doing over there. All right, so, Colin, I know you're doing the same thing. So I want to work on the determinant on the bottom. What does it look like for the entries for that determinant at the bottom? It's all what? I mean, Michael was just saying this. It's my coefficients, right? So 1, 1, -3, -2, -4, 5,
Now we're answering questions.
negative, -3, 3, and 4. What changes up top?
For a 3x3 or for how it's different?
Either way.
Yeah, it's like a specific thing on the end.
Replace the column of the variable that we're solving for with what? The answer, the constants, the solution. So the value is all the way to the right. So I'm solving for x. So then vertically, I'm going to put 2, 14, 0, and then the rest of my values stay the same. Yay. All right, cool. So then now we got to define the determinant. How do I do that again? Expansion by minors. Sounds good. I don't like the diagonals. I'm going to work, here's how I would do it for the top one. You said what?
I thought 5, 4, and 0.
5, 4, and 0, is that what you said? Okay, so the row on the bottom, Isabel, is what you want to do? Fine by me. So the first one's going to be 0, and then I'm not going to worry about putting anything else in there, okay? My second one that I'm going to use is 5. But what do I need to be cognizant of?
Negative.
My negatives, right? So do we remember the sign matrix? How that pattern works? No. All right, so then 0, and then we're going to have -5, and then we've got the value of our determinant in there. Do you guys want me to show it, or can I just do it in our heads? Can we do it in our heads?
I don't use this method.
I don't use this as foreign to me. All right, so either way, again, if I'm doing expansion by minors, I'm working on this cell right here. So then I need to do 2 times 3, which is 6, minus -3 times 14. So then 3 times 14 is going to give me 42. So then I'm going to have 6 plus 42, which is going to give me what? 48? Cool. And then plus 4, and again, it's plus because we're working on that part of the sign matrix there. So then plus 4. All right, so then here and here's what we're covering up. So I got to do that determinant, which is going to be -8 minus 28. Or I'm sorry, -8 plus 28, which is going to give me 20. Nice. All right, and then the bottom, we got to do expansion by minors again. The bummer is there's no zeros, so there's no making it any easier on us. So then in this case, I'm going to, I don't know, I would just work, I'd probably work the first column, TBH. So then I'm going to have 1 times, all right, so then if I'm doing the first one, I'm doing this. -16 minus 15. Thanks, Gideon. And then we're going to do, oh shoot, I left that subtraction sign there. -16 minus 15, I'm just going to write it. -31, right? Okay. All right, minus 1 times, all right, we got to do the next one, which would be here and here. So then -8 plus 15. -8 plus 15 is going to give me 7. And then for my final trick, I'm going to do plus -3 times, all right. So then we're doing that. So then we would do -6 minus 12, which would be -18. So then there's our values, okay? All right, so then we would combine all those values up top. Man, did I do that right for the first one? 5 times, what's that? -1 for what?
-4 times 4 plus 5 times 3.
Was that for the 18? Is that what you're talking about, Isabel?
No, for the bottom.
For the what?
For the bottom.
What part of the bottom?
The first one, the 1 times -31, what did you do?
Negative 16 minus 15.
Yeah. A, B, minus.
Because you do this product, Isabel, minus that product. Okay? All right, I think those values are right. I'm hoping that they are. 5 times 48 is going to give me what? 900, negative 960? No, that's not right. That's way too... negative 240. That's what it is. Okay, and then plus 80 divided by... Oh my gosh. Negative 31 minus 7 plus... $54. There it is. Sorry, you said that, Andy. All right. Oh, okay. I ran out of room. All right, super. So then that's going to equal, let's see. Up top, you would get negative 160. In the bottom, I'm hoping we get 16. Is that mathin'? Difference between 38 and 54? Cool. So then it's going to give us negative 10. So that's my value for x is negative 10. Great. Let's do it again. For y or z?
Z.
Ah. We're doing y. All right. Boop. All right, cool. And then we got to do our new determinant up top. So then we would get 1, 1, negative 3. Replace our y column with 2, 14, and 0. And then our final column, negative 3, 3, and 4. And then we spin the wheel again. Hey, the good news is, what do I know about my denominator? Oh my gosh, that's so nice. Then I don't have to do it again, right? But I do have to do the numerator. So let's do the numerator. Charlie, you may. So then let's do, I would say, our second column, right? So then we're going to do 2, or we can do our bottom row. Let's do our bottom row. Negative 3. Okay, so then this and this. So then 6 minus, or 6 plus, rather, 3 times 14. Did I do that already? 42. So then is it 6 plus 42, so 48? All right. And then minus 0. I don't have to do anything there, so just do minus 0. And then I'm going to do plus 4 times our final determinant, which is going to be 14 plus 2, which is 16. All right, 3 times 48 is 150 minus 6, negative 144. Yeah, take a 4, it'd be 12 by 12. Okay, so negative 144, and then plus 4 times 16, so 40 plus 20, 64. Thanks, Hannah. All right, so then negative 144 plus 64 gives me what? 80? Negative 80? Negative 80. So negative 80 over 16, which is going to give me an answer of negative 5. Something don't seem right. What did I mess up? Oh, it's negative 6. No, hold on. This number's wrong, right? How did I mess up negative 8?
96.
Is it negative 96?
Over 16, yeah.
No.
It's 4 times 12 instead of 4 times 16.
Oh, I think you're right. Caitlin's right. It is 4 times 12. Okay. Thank you, miss. That's how I know Caitlin did her study guide. All right, so then that's 48. So then that was, you guys said 96. Okay, so then negative 6 should be the answer. Cool. And then the famous question was, okay, well, can I plug that in for x and y and then find what z is without going through that wonderful process again? And yes, I would be okay with that.
What if we have a 2 by 2 after we find x, can we just plug in for
And miss out on all the fun?
It's a slippery slope.
It is a slippery slope. I'm worried that I should just tell you guys to do it all the way through, but I'm going to stick by what I said. So, it is what it is. That's a yes, Colin, unless I explicitly state otherwise. So maybe for a 2x2, I would just say, do it. We need to see augmented? Yeah? Okay. All right, here we go. Augmentation time. I don't have room. I'm going to erase this. Are you okay with that? Okay. One of the first things Michael asked me is like, tomorrow, can we have room? Yes, I made sure that there was enough room for you guys in your test.
I'm literally looking at the answer here now.
At what?
Literally looking at the answer here now. This is not good.
You just, okay. All right, augmented matrices, what does that look like again?
It's like with the dotted line.
With a dotted line, right? All right, so then 1, -2, -3, solution of 2, and then 1, -4, +3, solution of 14, and then, give myself a little more room here, -3, 5, 4, 0. Okay. The goal is to end up with a diagonal of 1s, 0s everywhere else, and then a solution set that I could work with, okay? Remember, no subtraction, because you got to use addition.
What about?
So what would you want to do first?
I
Let
get
us
it.
subtract
Something.
row
Plus.
2 minus
Just
row
do
1.
-1 plus -1.
-1, row 1, plus row 2. It's got to be addition. I let it slide on the quiz. I'm telling you now, they all have to be addition, okay?
What if I did?
Because
What if I did row
it's the rules.
plus negative row 1?
Row 2 plus negative, that's what I did. That's what I'm doing.
So,
But the negative has to go first. It's got to be represented as addition.
yes,
And you can't multiply the second value by a negative, because then that's just negative. Your negative must be listed first.
I can't put like row 2 plus negative row 1.
No.
It has to be row 1.
What?
Yes. Yep.
Buttocks.
It's got to be addition. And I know you plus and negative, right? I get it. But it represents where it's supposed to go is that second piece that's there. Okay? So negative row 1 plus row 2 is going to replace row 2. All right. So 1.
I'm going to forget that, please.
Don't.
Put a little note at the top. Just said no addition.
It's really not that hard though.
All right. So -1 row 1 plus row 2 gives me a 0. Negative row 1, so that would be +2. +2 plus -4 is going to give me -2. And then +3 plus 3 is going to give me 6. And then -2 plus 14 is going to give me 12. Okay. Now, I could do 2 at once though, right? What could I multiply row 1 by to have it interact with row 3? So let's do 3 row 1 plus row 3. So 3 times row 1 is going to give me 3. 3 plus -3 is going to give me 0. 3 times -2 is going to give me -6. -6 plus 5 is going to give me -1. 3 times -3 is going to give me -9. -9 plus 4 is going to give me -5. And then 3 times 2 is going to give me 6. 6 plus 0 gives me 0. All right, I like it. Couple routes we can take from here. What do you guys want to do?
The second row.
What about the second row, Gideon?
No, it's not the second route.
The second row? Okay. Ethan.
You should multiply the second row by -1/2.
I could do that. Let's multiply second row by -1/2.
Yep, that's the way to go.
Okay, so -1/2, row 2. All right. So So 0, 1, -3, and then -6. I like it. There's a lot of potential for good things to happen here. What should I do?
I think you should let Gideon take the reign.
Gideon, what do you think, pal?
Oh yeah. Yeah.
Let's talk strategy real quick before Gideon tells us, okay? We want to get, like, the first thing you want to do is you want to get a 1 in the top left. Ideally, that's the first thing you want to do. And then after that, you're eliminating the values below it. So you're getting zeros under here, okay? The next thing we want to do is we want to get a 1 right there. And then we're going to use this 1 to eliminate the value above it and the value below it. So then that'll give me a 0, 1, 0. And then I'll work with that last value once I get there, okay? So Gideon, in light of that, what do I want to do?
You can add row 2 to row 3.
Cool. So that'll eliminate that one. Let's do 2 at once, though.
You can multiply row 2 and add it to row 1.
So multiply row 2 by
No,
2, and then I add it to row 1. Are we all okay with that? So I'm going to do 2 and 1s. Okay. So then in that case, let's see. Row 1 or row 2 plus row 3. And then here, 2 times row 2 plus row 1. All right. I got to sit down for this one. Buckle up. Okay. So then in that case, I know. I'm sorry there's no room, guys. I'll have to make note of that in the futures to give you guys room on the study guide as well. Okay, so then 2 times row 2 plus row 1 is going to give you a 0. 2 times negative 3 is going to give me negative 6. Negative 6 plus negative 3 is going to give me negative 9. And then 2 times negative 6 is going to give me negative 12. Negative 12 plus 2 is going to give me a 10 there. And then let's see, 0, 1, negative 3, negative 6 did not change. And then I'm doing row 2 plus row 3. So then 0, 0, negative 3 plus negative 5 is going to give me negative 8. And then row 2 plus row 3 is going to give me a 0 there. Oh, that's really good. Because I could just divide row 3 by what?
Negative 1/8. Yeah, negative 1/8.
Cool. So negative 1/8 times row 3 is going to give me 1, 0, 9. Sorry, negative 9. Uh, 10, 0, 1, negative 3, negative 6, 0, 0, 1, 0. You may recognize that solution set all the way to the right. But the next thing that I would do, since z is equal to 0, it makes it really easy because now I can just multiply row 3 by 2 different things and eliminate the values that are up above that, that 1. So my next trick would be 3 row 3 plus row 2. And then I would do 9 row 3 plus row 1. Resulting in 1, 0, 0, 10. Oh, that should be negative 10. That's my bad. That's a negative 10. That's a negative 10. So negative 10. And then 0, 1, 0, negative 6. And then 0, 0, 1, 0. We've been augmented. Okay? All right. We did A, we did B. We're looking good. Questions there? Okay. All right. I think these ones are also not too bad. We talked about, I mean, there's just a couple more of those in there that were similar to our front page. So for the first one, you want to find the transpose of A. Hey, Mrs. D'Amico. That would be sublime. Thank you very much. So we find the transpose, we multiply it by 2, and then we take away our values for B. We have to hit the transpose in order for those to have the same dimensions to have it work out. Cool. And then find AB and BA. We notice that those are not the same. Why are AB and B times A not the same? Different dimensions, right? And we know that matrix multiplication is not commutative, okay? It's associative. So because of that, we're not going to get the same thing when we multiply A times B compared to B times A. Why is A transpose times B undefined?
Because it's 2 by times
Yeah. So, well, if I do like A transpose right now, 2 rows and 3 columns, so then it would end up being A transpose would be right now 2 rows, 3 columns, so it'd be 3 rows times 2 columns. And if I try to multiply that by B, which is 3 rows, 2 columns, then my inner products won't match. So it will not work out. So we have a dimensional error there. Okay. A children's toy store sells Mama, Papa, and Baby Bears, each in small, medium, and large sizes. During 1 week, store sold 7 small, 14 medium, and 10 large. It also sold 8 small, 10 medium, and 9 large, and 15 small, 10 medium, and 12 large baby bears. All right, so then it says express your information as a matrix S, okay? So what I did was I did the different types of bears, Mama, Papa, Baby, along the left side, and then the sizes along the top side, okay? You could switch that around if you wanted to, but that's how I would do it, okay? Next week, store expects to sell 50% more of each type of bear because of a special sale. How many medium-sized bears would they expect to sell? In terms of S, what matrix gives us the amount expected sales for each type of bear? Okay. So then this is what my matrix looks like. If you organized your information differently, it would just be the transpose of that matrix. Okay. But everything, they expect to sell 50% more of each type. So I just need to multiply each individual entry by 1.5. That would give me 50% more, okay? Please be sure that you're not multiplying by 0.5 because that's just going to cut it in half. We want 50% more. So we got to have that one value and then 50% more of that to combine with it, okay? We kind of talked about this already with 18. It just says give two by two matrices such that the products of them are not equal if we try to use like the symmetric property. And then write a sentence or two as to why matrix multiplication is not commutative. How would you try to put that into words? Why matrix multiplication is not commutative? What would you have to say about that? Why doesn't it work for us to switch those values? What do you think? The order of numbers wouldn't be the same. My dimensions would change. You could drop something about dimensions, right? Because, dimensions matter when you are multiplying these things. And then kind of like how Isabel said, the order in which you are multiplying those numbers will change depending upon where you put those matrices, okay? Even regardless of dimensional issues, okay? 19 is just another inverse matrix that's in there as well, too. We kind of went through that process already, so I don't feel as if going through that. And then we already looked at expansion by minors. We would definitely want to use the second column, the third column, because you've got 2 sets of zeros there, okay? And then we looked at how to do that a little bit already. With that, then you'd have to boil it down to, then you've got 3 by 3 determinants for each one of those that you would have to go through and find. Takes a bit of work, but not impossible, not too bad, okay? Now, as far as some of the practical application problems, things that I want to mention, with 21, so they tell you like your mix of nuts that you'll have there. There's a regular and a deluxe. They give you P already. And then it says use the amounts given to write a matrix N representing the total weight. So they give you these values here, 12 pounds of the regular, 12 pounds of 4 pounds of the deluxe. So if we are to write a matrix for that, note that we want to make it a 1 by 2 matrix instead of a 2 by 1, okay? Because then when we multiply those by each other, we got to make sure that those dimensions line up with each other. So that's why we want to have 1 row by 2 columns. So then you just go through and do that multiplication, and you end up with that matrix that we get there, okay? So how many pounds of cashews do we get? 2.8 pounds of cashews. And then we've got our communication matrices for a couple of these problems. These ones I don't feel like are too bad, even if you haven't looked at them in a little bit. Remember, we wanted to write a matrix that represents the information in that picture. If it's a connection between one computer and the other, or ship, or whatever we're talking about, then a 1 goes in that corresponding entry, okay? And then we always go, like we did this for a couple different sections, but we go from the left side to the top side. So if we're going from computer A to computer B, we see that we can go from A to B. So that's why there is a 1 as an entry in that spot right there. Okay. We also did that with transition matrices as well too. We went from the first initial month, and then 2, we put that across the columns of the top for the other one. Okay. All right. And then this one, you have to be careful about how it's worded. So you have to find M squared. Which computer has the greatest number of 2-step paths to it? If we're going to it, that's why we want to add vertically instead of horizontally, because we're going to that value. Okay. If we were going from it, then we would do it horizontally. But since we're going to it, we would go vertically. It works along that part of the top. Another communication matrix there. And then these ones I feel like are really not that bad. That's the last section I taught you guys, so I don't really want to point anything out there. So yeah, those are transition matrices. I don't feel like those were too bad. Transformation matrices, remember the order that we do that? We would do the transformation matrix first, multiplied by our coordinates. So transformation matrix first, multiplied by my coordinates to end up with our image. So make sure you go back and look at those values, okay? All right, if you want me to go over anything else on this this key, please come see me during one of your free times before school or after school. If you do intend to come at a certain time to ask questions about the key, let me know so I can try to make my best effort to make sure that I am here ready for you. Okay? Good luck, friends. Have a great day and go Minutemen.
We're not gonna see